which you sent, and I have seen all those. So I will divide and I will make all those slides concerning all those problems. So let's see. First is that there are a lot of questions about this. So I have gone through all those, what we can say that was LMS, some of the college that may be of your school. But anyhow, so I have selected in this way that we should talk about each and every problem one by one. So our today's topic is, so I'm sure that the end of this, you will be in a better position to find the domain and the range from graphs step by step. So if the graph is given, either it is a linear or what we can say the, am I audible to you?
Yeah, I can hear you.
Okay, okay. So it's nice. So you can find the domain and range. So step by step, we will proceed on because a different type of the graphs were given when I saw all those problems which you have sent. And practically, I log on to that Delta Math site LMS system. So that was very interesting, and I'm sure that if you are getting all those problems, so you keep on sending me. So I will actually I have divided those problems into topic wise because those were the what we can say different type of the things were there. So it's a this way is a better that we should learn how to solve the problem instead of we are just going to solve those problems one by one. So in this way you can solve 100 problems just like that. So how to find domain and range from graphs step by step we will discuss. So first is that the question was that was in those graphs that find domain and range from the given graphs. So whatsoever the graph is given, this is a unique way that we can find the domain and range. How can we find? So this is the question, and definitely in the next minutes we will solve all these ways and means how to find. So actually, uh, what is the domain of the function shown in the graph below? So this graph I have selected from your problem that was what we can say these type of the curves were given and we were looking for that. So only the graph is given and we are just finding out the domain and range of this line, this curve. So let's see how can we find this. So the next
Okay.
slide is if you can read, please. This time you must read
Sure.
it. Yes.
Way to identify the domain and range of functions by using graph.
Using graph. As the graph was given, a lot of graphical problems were there, and you will learn that whatsoever the curve is, whatsoever the graph is, the method is very unique. So let's see that how many steps are there and how can you find. The domain refers to, first of all, we should keep this thing in mind that domain refers to the set of possible input values. So domain possible input values. That
Yeah.
what are those values we can put in the graph and input values because graph is basically describing the function, a pictorial view of the function. So that's why that we should keep this thing in mind that when we are looking for the domain, so actually we are looking for all those values which are possible inputs for those functions. But anyhow,
Okay.
so after having this much knowledge about the domain of graph consists of all the input values shown on the x-axis. So actually we have all these graphs have been drawn on the axis, the coordinate axis. That is the plane, the two lines, mutually perpendicular two lines. meeting at a point that is called the origin. So from here, one thing is crystal clear that the domain, all those values which are in the set of domain of any graph, those must be along the x-axis. So those are shown on the x-axis. So there is no value of domain that should lie on the y-axis. So we will have to focus on the x-axis. So one thing is, now the next thing is, and the range is the set of possible output values which are shown on the y-axis. So from here we can say that whenever we are looking for the range or the domain, so we'll have to focus on the x-axis. All those values which can be drawn, which are the parts of a curve along the x-axis, all those values, the collection of those values, the set of those values will determine our domain. And all those values which can be drawn on the y-axis of the graph. So those values, the set of those values, we can obtain the, what we can say, the range of the function. So this thing is very basic and key to the solution of any problem, any graph, that all those values along the x-axis will consist of domain, and the range is the set of all those possible outputs which are along the y-axis. So domain is input values and range consists all those outputs. As we know that the function is a combination of inputs and the outputs. So let's see how we will find this. Let's see. So this is once again the example. What we can say. So this graph I have selected from that Delta Math site or LMS. So that was the learning management system. So here, if you can see that this is starting from here. What I mean to say, this dark dot, if this dot is filled, so this end point or this starting point is included. It's coming down,
Okay.
crossing the x-axis and then crossing the y-axis, then going here and then coming back, and it's an arrow. Arrow means it's a still continuation. There is no stop.
Right.
It's going down, down, and down. So we are looking for the domain. So graphically, if you can see that because we just find out all those values, possible values, which are lying along the x-axis. And here, this is the
Right.
x-axis and this is the y-axis. So I have drawn this line, that is the orange line. And this line is starting just about the beginning of this graph. So look at this. So I will have to move along the x-axis. So along the
Right.
horizon, the horizontal line that's starting that covering this graph starting. So I have started with the fill dot. Fill dot means inclusive. This point. So
Right.
this point is inclusive. So I am just moving on because my curve is just going on. So my orange line is just moving. And here, and here, I will have to look at this, that my line is just coming over here. So it's just bending down. What I mean to say that this curve is not moving along the x-axis. All of a sudden, it's moving along the x-axis. And at this point, going down, down. And it's now here, you can see that no movement along the x-axis. What I mean to say, it's totally turned down in downward direction. And there's no sign of any trend to move left or right. What I mean to say, along the x-axis, along the parallel, along the horizon.
Yeah.
So from here, so that's why I have selected this point, that this is the only area, this is the only area where the curve is moving down. And from here up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down. And from here, up till this point, the curve is moving down It's moving left, right along the horizontal, and when reaching over here, it's all of a sudden taking the downward journey. So this is the only possible area which is along the x-axis. So this curve is traveling this much along the horizontal. What I mean to say, along the x-axis. So my domain consists of all these intervals which are horizontal, which are along the x-axis, which are parallel to x-axis. So this curve in the entire journey, just moving this much area along the x-axis. So my domain consists of starting from this point and ending this, because this is the point where there is no further movement along. This is the point where no further movement along the x-axis.
Right.
Now it's coming down. So we have this much area along the x-axis. So all these points, the set of domain will consist all these points. And from here we can say that this is starting from -5. My orange line is just matching to this -5. And the orange line is just coming to 5. What I mean to say that this is the point where the arrows are going down. So that's why we can say that range consists of these points. So starting from -5 and ending at +5. So my domain consists of all those points which are starting from here inclusive, because there is a dark dot.
Yeah.
And I'm sure that you got this one. So
Yeah.
is there any question or any query? So
Yeah, just one thing. So for the domain and range, will we collect all the points? So 5 to
yes, it's a
-5?
good question. We will talk about that. So let's see. Actually, we have starting this one. So this is moving downward as well as moving to the right. Here the same case is going over here, and this is still in the what we can say horizontal track. So from here it's coming down, but still slightly moving to the right, and you can see this. The gap is widening, and when it is reaching over here, so it's end up. There is no question that further it will move to the right or left.
Yeah.
It will go downward. So the visible part, we are concerned about the visible part. It's because it will go through the journey along the y-axis, and it may come and go in this way and zigzag. But here, what we can see in the picture, so our range, we are just bound to collect the range from this point to this. That is the visible part of the curve. So always you will have to observe, or you will have to collect all those values which are visible to you, because we don't know where it will go. But from here we can say that our journey is stopped along the x-axis. So it has started its journey along the y-axis now. From this is the point. So that's why we can say that this is the whole region starting from here and ending out here along the x-axis. So that's why our domain will consist of all these points which are lying between this point to that point. I'm sure that answer is done. Okay. Now let's see. So please read this one.
Sure. If the graph continues beyond the portion of the graph we can see, the domain and range may be greater than the visible values.
Visible values. So this was a question, I hope, and this is the perfect answer. If the graph continues beyond the portion of the graph we can see only that portion, the domain and range may be greater than the visible values. But we can say that may be greater, but we are interested just to locate those values which are visible, because the problem is whatsoever the graph is given, so we are concerning about that. So we are just focusing where it is starting and where we can see its end, where we can see, that is a visible part. I'm sure that this is the right answer. of your question. You are asking about this, I'm sure.
Yeah, pretty much.
No, you are just getting the answer. Now let's see. We can observe. Now look at this. We can observe that the graph extends horizontally from -5. As I was saying that this is starting from -5 horizontally from -5 to right without bound. So the domain is -5 and infinity. Infinity means that if you are just coming down to this one. So as we can say that we cannot nominate any value. We cannot nominate any value. But we
Yeah.
can say that it's if this downward journey is continuous, so we cannot nominate. So that's why from here this 0.5 is that we will have to put the arrow. What I mean to say that 0.5 is our visible range. But what we can say that if there is an arrow, if there is a just like this point, if there is a close end, then we can say -5 to 5. Our visible values are although 5, but if we can think about that, that it may go slightly left or right, especially to the right, we are not sure about that. Only this part. So from here we can say that instead of putting 5, that is the end value, we are just putting the arrow. Are you getting this? We are just putting the arrow. Arrow in the sense that we are not sure about that, because if there is a dot, what I mean to say, if what we can say the point is just like that, if there is a dot over here, let's suppose if it is putting the dot over here, then what we can say, there is no arrow. What I mean to say, this dot is over here as it has been starting from this dot. So if this is a closed curve, what I mean to say closed curve, then we should end it at this point where this is 4.5 or nearly we are half. But still you can see that this is going downward, but it may go right. So from here, to be on the safer side, we should put infinity. Are you getting this point? This is a very critical point in the sense, because if the arrow is there, so what we can say, put the infinity, because we should not write this 5 because we are not sure about that. This is a continuation. So this may turn back to this point. What I mean to say, it's going down and all of a sudden it is taking to the right. So this arrow is the sign of continuation. So that's why we will have to observe the value seen on the graph, and if the arrow is there, so we will have to continue with that. So -5, that is the starting point, including this point, because it has a dark filled dot. So -5 and infinity. I'm sure that now it's clear that ambiguity was there in the beginning, that if there is the arrow, that curve is not closed, it is continuing and we cannot see all those values. So we will have to decide either it is going to the positive trends or the negative. But here we are not sure about that. So we are just to be the safer side. This is the open end also. What I mean to say, can you see the difference? This is the close end. This bracket is for the close interval. What I mean to say that -5 is inclusive. And here we are putting infinity and we are just putting this this line. So look at the difference of these two lines. This bracket signs indicates that this end value is included. And this indicates for the open interval, exclusive interval. So -infinity is inclusive. We are not sure about that. So that's why, to be the safer side, we are just what we can say, that we are excluding infinity. Are you getting this difference?
Okay, yeah.
Because this sign is for the inclusive interval and this is for the open. That we should not say that this is infinity is included. but its trend is that this is excluded. -5 and then onward, or end point is infinity, so it may stop anywhere. But I mean to say, infinity mean that this is or the open end. Are you getting this?
Yeah.
This is the inclusive and exclusive event. When the two endpoints are included, as I was saying, that is indicated by dots. Then we will have to put this sign, this bracket. This square bracket is actually saying, indicating that this -5 is included our domain. But this open end, this small braces, this is indicating that this point, this infinity is not included in our range. So that is the end point, but that is not included. I'm sure that you are getting this. Okay, you are getting this. Now let's see if we are just going to what I mean to say, the next slide. So there is one more thing that is that, look at this. So yes, now you can see we are looking for the range. What I mean, so this was the domain and now range. The vertical extent of the graph is all range values 5 and below. So the range is, now look at this. So it is starting from what we can say that this is starting from here -5 coming down as well. So this is what we can say starting from, and this -5 is for the x. And if we are looking on the y-axis, because range is that is all those values which are lying on the y-axis. This is our y-axis. So if we can parallel to this point, so our curve is starting from, look at this value, that is +5. So we are just putting another line. So this line is indicating our range. Now from here you can see that it is starting from 5. So 5 is, once again there is a dark dot, filled dot. So that's why this 5 is included. This 5 is included. And it's coming down, coming down, coming down, and crossing the x-axis and crossing the 0, and it's just going to the negative values. So it will continue its journey. Look at these two arrows. So what we can say that 5 is once again inclusive, and we are not sure about this, that where it will stop, but its trend is showing that it is going to the negative values of y-axis. Look at this. So it will continue its journey to the infinity, and this is the minus infinity. And as you know that 5 is greater than the negative values. So these are the greater values and these are the smaller values. So positive are always greater and negative values are always smaller. So when we are writing the range, so we are starting from the smaller value to the greater value. So once again, you can see this is exclusive, minus infinity. It's moving towards infinity, but in this negative direction. Are you with me?
Okay, yeah, I'm understanding.
Oh, yes. So it's good that once again we are in inclusive, exclusive infinity. And 5 is very much included, inclusive, because we are putting this bracket. But it's a way to write from the smaller to the greater value. So that's why we are starting minus infinity. This is open interval and this is a closed interval. That 5 is inclusive. 5 is included our range, and minus infinity is exclusive. But this is just talking about that smaller value to the greater value. That's why we are putting minus infinity with the open end and +5 with the closed end. So this journey along this line, along the y-axis, along the vertical line, that is indicating the range. I'm sure that you can find the domain and range of this curve. Simple. Is there any confusion? You can ask now.
No, not about this.
Okay, yes. One thing was that this indication that where it is going still or stopping anywhere. If it is stopping over here, so the range will be -8. If let's see, as last time what we were saying, that if it is stopping over here, what I mean to say, if there is an end point just like that and fill dark, then domain is -8, starting from -8. -8 is inclusive and 5. If it is open end, what I mean to say, that if there is if it is stopping over here with the open end, just like this, unfilled point, then our domain is -7, open end, and +5, -7 and +5. Look at this. If our circle is once again what we can say open, unfilled dot, just like that. So what we will have to write, that this -5 is now exclusive. So we put the same parenthesis over here. So what we can say, that should be just like that. That is also just like that. So now this. So these are the open dark. What we can say open end, unfilled ends. So these are exclusive. I'm sure that now this is the difference between the dots. So the next thing is, so I'm sure that all those curves which are given to you, so in this way, just putting the lines, you can determine the range and the domain. And now let's see. The next is, what I mean to say, okay, this was the previous one, and now we are moving forward. So this, please read this one.
Sure. The domain and range are always written from smaller to larger values of left to right for domain, and from the top of the graph to the top of and from the bottom of the graph to the top of the graph for range.
Okay, this was the thing that when we are just putting it into the interval, so we will have to start from the left smaller value to the greater value. All about domain and range from top to the bottom. I'm sure this is clear to you. So example, now let's see. Example, please read this one.
All right, finding the domain and range from a graph. Find the domain and range of the function whose graph is shown in the figure.
In the figure, now figure is coming, this one. So it's your turn now, if you can do this.
Yeah, so the domain
is, yes.
-3 to 1.
Oh, yes, absolutely. But this 3 is exclusive.
Wait, okay. Isn't it a point, or is that like something else?
No, it's an open end and it's a close end.
Oh,
look at this. This is unfilled. As I was saying, this is small braces, and starting and ending at the one, that is the square bracket. I'm sure that you can write this just like that.
Okay, so that would mean
just like that. Okay, just like that. -1, -3, and this is the inclusive event 1. I'm sure that this is the best answer.
Yeah, that makes
sense. You see? Can you see my writing on the slide? Okay, so there is a difference that I am putting this braces because this is unfilled dot line, unfilled dot. Unfilled dot means exclusive. This 3 is not included. -3 is not included. It is starting just below of -3. Okay, I'm sure. Now, what about the range? So, what about the range?
So it's from bottom to top. So it'd be -4 to -3, but it's not inclusive.
Yes, but this is once again inclusive event.
Oh, sorry.
Starting from the square bracket, ending at the braces, small braces. So you can write just like -4 because smaller. We will have to start from the smaller to the What I mean to say, now one thing is that you are committing the mistake. Now let's see. This line is actually starting from and reaching at the maximum 0. So what should be
Yeah.
your range?
So it's -4
To
inclusive to 0.
0. 0 is also the part of that. 0 is once again inclusive because it's rightly going to the 0, touching the 0, not this open spot. So your range is, if I can write for you, so let's see, you can match your, so that should be just like that in the closed interval. This is -4 to 0. Am I right?
Yeah.
Are you getting this? So this is the only vertical line we can put just like that. This is the only vertical line. This is the range. So you can say this is the range. And that was the, what we can say, domain. There is no arrow, closed end. I'm sure that it's clear. Anything you can ask about that if something is confusing. So let's see. We are just moving to the next. What I mean to say that is the next one. So here the solution. We can observe that the horizontal extent of the graph is -3 to 1. So the domain is -3 and 1. As I was saying that exclusive and inclusive. This is open end and this is a closed end. Same problem with a solution. And you can see the line just like that. Can you see this?
Yeah.
This is domain and range. Absolutely, that was the line. So what we can say that the range is, the vertical extent of the graph is -4 to, what we can say, 0, -4 to 0. That was the absolute answer. And you can see this line. And we have this, both ends are closed with the square brackets. Find the domain and range from the graph. I'm sure that you can find this. Can you find?
Sure. So the domain would be they're both would be no, not inclusive, exclusive, because they're both arrows. So it's gonna start at, it looks like, would it be just -1?
No, it's just -2. What I mean to say, from here, this is going over here, here, and what we can say that this is the point where it is once again crossing to the left. And you see this?
Okay.
So from somewhere here, it is coming down. From here or here, because it's a journey along the axis, both sides. So it is crossing, and then once again, it's away from the y-axis. So this journey is to the negative parts. So what we can say, this is -infinity to +infinity. Can we say exclusive both the infinities?
Okay, so that would make it, wait, what would it be then? -2 to infinity, or 2 to infinity, and then it'd be
Range is, look at this.
Okay.
Look the lines drawn. So from here you can see this is the vertical line coming down, and these are the lines horizontals. So the horizontal lines you can see as well the vertical lines, and this is when what we can say, from this you can just locate the, what I mean to say, the range. Range is starting from -10. Can you see this -10?
Yeah, I can see that. Yeah.
-10 is exclusive. We are not sure about that. And that will continue. And from here, you will get this. So I'm sure that you have the idea, we will talk a little bit in the next lesson also. We will talk about the quadratic functions, how to find the lines. So this was all about that. So it's a time to say goodbye. I have to go. So thank you very much for today. Okay. I will send the solution of other curves also.
Okay,
Okay. Thank you very much.
right. Allah Hafiz.